Whoa.
Okay, that's exactly right. Hey, we're here with eighth period. Everybody say hi. Okay, we're going to get started. We're looking at question 274, and that is on page 53. 274 on page 53. Okay, so coming up, I will tell you more about what your test is going to be like, but let's look at these questions. It's by Hafsa. Okay, so first of all, it says which graph could be used to find the solution? Oh, this is one you don't have to do for your test. Cross it out. Yep, 274 you don't need for your test. Cross it out. All right, number 275. Here we have a diagram. It tells us that, make it bigger. It tells us that AB is 104. It tells us that these chords are parallel. Because those chords are parallel, we know these arcs are equivalent. That's very important. It tells us this is 104 and arc CD. Now look at this. See how this is the diameter of the circle? Ish. CD is less than that. So this section of CD is what's 168 degrees. Not the other section, because that other section's bigger than the diameter. So this little section's 168. So what we have to do is we now have to figure out, okay, what's the missing pieces? Well, because they're congruent, we know that they're going to be equivalent. So I'm just going to put X and X. How many degrees are in a whole circle? Excellent. X plus 104 plus 168 equals 360. I'm left with 2x plus, thank you, 272 equals 360. Subtract 272 from both sides. I'm left with 88. And then divide, and I'm left with 44. So a lot of this is just algebra, but we have to kind of put it toward geometric principles. So the catch is this 168, some people would have had this larger major arc be it, but had they said CBD, then we knew it would be that way. But because it doesn't, we have to do the minor arc, which is 168. Okay, go on. 276 says, in a park, two straight paths intersect. The city wants to install lampposts that are both equidistant from each path and also 15 feet from the intersection of the paths. That's very interesting. How many lampposts can they have? Two straight paths intersect. I might get this wrong the first time, but let's see. The city wants to install lampposts that are both equidistant from each other. Oh, nope, we're fine. So all we're going to do is it wants 15 feet from the intersection. So from here, the intersection is a single point. So here's my single point. That's where they intersect. Because it wants 15 feet from it, I can go 15 feet this way, 15 feet this way, 15 feet this way. Remember that whenever we do the locus of points, all we're doing is drawing a circle. So I would draw a circle with a radius of 15 and see how many times it intersected the blue lines. So I've got it, here's 1 time, here's 2 times, 3 times, 4 times. So 4 lampposts are needed. You will probably have a locus of point question because it relates to vocabulary, but I don't know if it would be this intense. This is a little bit harder than what you might end up seeing. Okay. Number 27, it says the circle has an equation of this. Is this a negative sign?
Yes.
Okay. What are the coordinates of the center? Well, we know we always switch the sign. So we know our center is +2, -5. So right away, we know it's not choice 1. I'm assuming that says -2, so it's not choice 3. So now we're left between choice 2 and choice 4. It gives us 32. Well, that 32 is what r squared equals. So when we take the square root of this, we're left with r equals the square root of 32. Now, you are going to have a not very wonderful calculator when you take the EOC. You're going to have a computer calculator, and it's not going to have a whole lot of stuff. So the easy, nope. We're allowed to give you one 4-function calculator, which is like literally $1. Yeah, it's like the teeny ones that are like this big, or the computer one. So all you need to do is just do the square root of 32 on the calculator and get a decimal. When you do that, the decimal I got was 5.6. So now I'm thinking, does 5.6 equal 16? Nope. So it's got to be choice 4. You also could, in your calculator, to double check it, is put in the square root of 2, hit equals, then multiply it by 4, and you'll get the same answer, 5.6. Excellent, good job. You guys, see, 8th period's become my favorite class. Yeah, isn't that insane? They can watch it. I tell it to them all the time. Okay, 278. Well, my favorite grade A class. 278. We've got AB has endpoints of 2, -3. That's A. And B has endpoints -4, 6. Now, very clearly, when I look at this, I did not put this in the right order because negative would come on the other side. But it doesn't matter. This is all it is it's a sketch to help me be successful. Midpoint, I'm going to use the midpoint formula. Midpoint formula is add the x, divide by 2, or x plus 1 plus x1 plus x2 divided by 2. So I've got 2 plus -4. So if you do that on the calculator, 2 plus -4, you're going to get -2. -2 divided by 2 gives you -1. So I can eliminate choice 1 and choice 4. Then I'm going to do the same thing for -3 and +6. So -3 plus 6 divided by 2. That gives me 3 divided by 2, or 1.5. So it's choice 2. Okay, that's okay. Question 279. In the diagram below of parallelogram, so now we know we probably will have something with angle measures. Parallelogram ABCD has diagonals ACBD. The measure of angle 1 is 45. The measure of angle DCB, so D to C to B, this whole one, is 120. What's the measure of angle 2? Oh, this is fun. So there's a couple different ways you can do this. One, you can remember that in a parallelogram, 2 angles that go in a row are supplementary. So we know that this entire thing here plus this entire thing here is going to equal 180 degrees. So we can do like 120 plus 45, and this is the angle we're trying to figure out, plus x equals 180. So this gives us 165 plus x equals 180, and then subtract and get 15. That's one way that you can do it. I'm going to show you another way because someone else might prefer the other way. The other way is, because this is 45 here, if I look at these lines, AD and BC, I know that this 45 right here is an alternate interior angle, which makes this 45 degrees. So you also could look at this yellow triangle and do the same exact thing, trying to get this angle based on the triangle. So you could either do alternate interior angles, or you can do same side supplementary. Either one. Okay, no big deal. 280, it is a raccoon. A quadrilateral whose diagonals bisect each other and are perpendicular. Well, because the diagonals bisect each other, we know right away that's a parallelogram. So we have to make sure that whatever we pick is a parallelogram. And it says perpendicular. The ones that form perpendicular are rhombuses. So it's number 1. If it was a rectangle, it would have to say the diagonals are incongruent. And then we pretty much don't consider a trapezoid a parallelogram, which is depressing. But. Okay, 281. Triangle ABC. Just draw a triangle. It doesn't have to be pretty. We're going to label it ABC. It tells us A is X, B is 2X plus 2, and C is 3X plus 4. I wish you get a ton of these questions because they're super easy. What do you think we're going to do? Yep. And then have them equal to what? Excellent. Add them all up. And have it equal 180. I intentionally put the x's first. This gives us 6x plus 6, 180, 174, 259. X equals 29. That would be so nice if we got a lot of those questions. In the diagram below, we have a regular pentagon. Are you going to have to do this one? You will not have to do this one. You can cross up 282. It's not something we teach down here during geometry. Number 1, this one. First, you have to figure out how many degrees is a pentagon. So then we would do 180 times 3. So that means a pentagon has 540 degrees. And then we divide that by 5 because there's 5 angles, which means each angle is 108 degrees. And then I have to figure something else out. Oh, these are, I think we have to do it because those are isosceles. Yep. So then these are going to be the same measure. So this is 108. And a triangle has 180 degrees. So you would do x plus 108 equals 180. Subtract. Now we know that this piece right here is 36 and this piece right here is 36. And then you take this whole angle, which is 108, and subtract the 36 and get 72. Insane. That's how you would do it. I know I did that fast, but. All right. This one, the lateral faces of a regular pyramid are composed of, so this we don't really need to know. The answer is isosceles triangles. It's just checking, do you know what a pyramid looks like? And because it's a regular pyramid, it has to have, the sides have to be the same going up to the peak. So that's just number 4. Okay, next. You guys are doing good. Let's finish this page, then we'll brain break. 284. In the diagram below, the length of the A legs AC and BC form a right triangle, 6 and 8. The altitude is drawn, CD. to the hypotenuse, what is the length of this piece? So basically, this is what we're going to do. How do I want us to do it? Wait, what? Hold on. I don't know if they want us to do Pythagorean Theorem first. Yeah. Okay. So we can't do this problem until we know what this hypotenuse is. Because basically what we're going to do is we're going to draw two triangles. Here's our first triangle, ACD, where AD is X and AC is 6. Our second triangle is going to be the big green triangle. Izzy, thank you for not distracting people. So in this case, we have 6 here and 8 here, but that doesn't help us because we need to know what the hypotenuse is. Yep, that's it. Oh, I had a little brain fart on that one. Point P. Point P is on the line M, so let's draw a line M. And point P is on it, so we'll draw the letter P. The question is, again, I don't think you're going to have this one. What is the total number of planes that are perpendicular to the line M and pass through point P? Yep, you won't have it. The answer is 1. Yep. There's only one thing that could go through it.
I don't want the question like this.
36 or 286. I don't even know why I said 36. Jeez Louise. A transversal intersects two lines. Which condition would always make them parallel? So I'm going to draw two lines cut by the transversal and just figure it out. Vertical angles are congruent. Well, that doesn't help me. Vertical angles look like this. It has nothing to do with parallel lines. So it's not choice 1. Alternate interior angles. Well, these are alternate interior angles. Are alternate interior angles congruent? Yes, so it's 2. In order for it to be 3, it would have to be corresponding angles are congruent. In order for it to have been 4, it would have to do same side interior angles are supplementary. That's how you would make it true. Okay. 287, 2 more questions and we'll brain break. Thank you guys, you're being fantastic. The diagram below shows a pennant in the shape of an isosceles triangle. The equal sides of each measure 13. The altitude is this. The base is this. What's the length of the base? Well, if this whole thing is 2x, how much is half of it? Yeah, 1x. That's right. So now we have to do the annoying Pythagorean theorem because it's got all these gosh darn x's in it. We have to do x squared plus x plus 7 squared. Exactly. So, yeah, but the thing is with the x plus 7 times the x plus 7, you have to remember to distribute. So you're going to end up getting this. So when I put that in down here, it's going to impact my answer. Mm-hmm. Yeah. I'm trying to see if there's an easier way, but that's the only way I can think of to do this problem. Right, it is. Nope, there's not an easier way to do this problem. Oh, we're not done yet. I won't. So then now I'm going to switch colors. So now that we did that, we have to simplify. So when we simplify, we get 2x squared plus 14x. And watch this. I'm going to subtract 169 from both sides so I can set it equal to 0. Oops. Oops, sorry, wrong button. Now see how there's a 2 in front of here? I need to get rid of the 2, so I'm going to divide everything by 2. Let me scroll up so you guys can see better. So this leaves me with x squared plus 7x minus 60 equals 0. And then to get 60, you guys probably remember this from before. You can do 60 and 1, 30 and 2, 20 and 3, 15 and 4, 12 and 5. That's the one we want, 12 and 5. Because we're trying to subtract them to get 7. So then this becomes x plus 12, x minus 5, and then you have to set each of these equal to 0, so we get x equals 5. I don't think you'll get one that extensive with the squared term. Or maybe you will get one, so to make sure not everyone gets 100, now that I think of it. This is like a higher level question. But it's just got a whole lot of algebra going on. Okay, last question, then we'll brain break. In the diagram below, we have medians. Remember, medians separate this circle into halves, and this middle point right here is called the centroid. And then there's a little rule about that. It says that whenever you have a centroid, that this top part right here equals 2 times this. So this right here would be 2x, and this right here would be x. And actually, P2 noticed something a lot easier. He just says if you get the bigger one, divide by 2 to get the smaller one. If you get the smaller one, multiply by 2 to get the bigger one. So here it says CF, this entire thing, is 24. What's the part of this smaller piece? Yeah, so that's going to be x here. This is going to be 2x, and that's it. X plus 2x equals 24. 3x equals 24. X equals 8. If it said what's CG, then we would do 8 times 2 to get 16. So let me just end the broadcast. Go ahead. We good?
Just have to pause.